Yesterday, we talked a little bit about linear pairs, vertical angles, and identifying them. Now, we're not getting into proofs quite yet, but to help prepare us for our proofs, we're going to have a postulate sheet, and we're going to be filling things in as we go throughout Chapter 3 a little bit. Including, we're going to start off with the first two items on our postulate sheet. Yesterday we learned about the linear pair postulate. Now when you are coming across something that would require the linear pair postulate, can you put the laptop away please? Thank you. When we're coming across this is going to be something we get from a diagram. In other words, it's going to be something we get from a picture. And if you see a picture that looks like this, where I have a linear pair, then I can say angle 1 and angle 2 are supplementary. That's what the linear pair postulate gives us. If I see stuff that looks like this, where I have some vertical angles, I can use the vertical angle theorem or the vertical angle congruence theorem, and I can say angle 1 is congruent to angle 2, or if it's the other pair, I can say angle 3 is congruent to angle 4. My vertical angles are congruent. Today, we're going to be getting into some other types of angle pairs, which we're going to come back to that here shortly. But if you do not have your notes packet out, you should grab it and open up to page 5. That's where we're going next. When it comes to the angle pairings that we've talked about so far, our angle pairings that we introduced in the first section, both types, linear pairs and vertical angles, and technically adjacent angles, they all have the feature that they share that middle vertex. But there are other types of angle pairs that form if we have a more complex picture. Specifically, that more complex picture is going to have something in it known as a transversal. A transversal is a line that intersects two or more other coplanar lines, just at different spots. So it intersects two other lines at different locations. Looks something like, if I have two lines, I'm going to call them F and G. Remember, if I'm going to call a line by a single letter, it's going to be lowercase and next to the arrows. Oftentimes when we talk about a transversal going through them, we say it's being cut by the transversal. So the transversal goes through them. And that's the transversal that I'm going to call T. Now when you have two lines being cut by a transversal, it actually creates 8 different angles. One here, 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 one here. It creates a lot of angles. And we can create pairings with those angles that are going to have special features as we continue to move forward. These new angle pairings are never going to be angles that share the same vertex. If two angles share the same vertex, such as this one and this one, both have a vertex right there, they're a different type of angle pair. They could be just adjacent, or they could be vertical, or they could be a linear pair, or maybe they don't have a name. In this case, those two would be, what kind of angle pair? The two that I put the dot on. It's a linear pair. So, when we're talking about our new angle pairs, they are not going to share a vertex. One of them is going to have the top one as a vertex, one of them is going to have the bottom one as a vertex. Now, off to the side, there are examples of the 4 different types of angle pairs that we're going to talk about. But when you have 2 lines cut by a transversal, there are multiple sets of these type of angle pairings happening, not just the one that's pictured. I give you the one that's pictured just to give you kind of a starting point. The first type is when you have 2 angles whose positions are on the same side of the transversal. So in this picture, this is my transversal because it's the line that's going through the other 2. Do you notice that they're both to the right of it? It doesn't matter left or right. Do you notice they're on the same side of it? They're both on the same side of it, and that's a key thing of this angle pairing. And then they're both in the same kind of corresponding position compared to the 2 lines being cut. In this case, they're both above. That is known as corresponding angles. Or for short, we just say CA. Now, on the other hand, if you have 2 angles whose positions are on the opposite sides of the transversal, so since my transversal is kind of vertical-ish here, I'm talking one's on the left, one's on the right, but they're both in between the 2 lines being cut, they're known as alternate interior angles. Or AIA for short. Alternate, that word is trying to tell us they're on opposite sides of the transversal. Interior is trying to tell us that the 2 lines that are being cut, they're between them. They're in the interior of that piece. Now, if I have 2 on the opposite sides of the transversal, but this time they're outside, they're alternate exterior angles. And I'm just going to re-emphasize a fact that I already said. In that picture, I am giving you exactly 1 pair of the angles that fits that description. In this case, they're labeled angle 1 and angle 8. But this angle and this angle are also technically alternate exterior angles. This one, and this one are both alternate interior angles. Corresponding angles, there's a lot of pairs of them. Okay, last type of angle pairing that we're learning about today is known as consecutive interior angles. 2 angles whose positions they're on the same side of the transversal, but they're both inside of the lines being cut. CIA. And before we move on to the next page, just a little reminder, we also have angle pairings that we talked about yesterday. Angle pairings that look like this, where they share that middle segment, and then they create that line that is a linear pair. It's not the postulate, that's just the pair, or LP. And then when the X is formed, the ones across from one another are called vertical angles, or VA. So those are important ones to know too, because those are going to continue to come up. So, on the next page, first thing we are going to do is just recognize angle pairs. Label the transversal T and name the relationship between the given angles. The transversal is the line that cuts through the other two. So, top line, bottom line, or the one that's diagonal? Which one's going through the other two? The one that's diagonal. That's the transversal. I'm going to label it as T. And then it says name the angle relationship. To name the angle relationship, there's a couple of different things we have to check. First off, we're going to check if they share a vertex, because if they share a vertex, put the laptop away. If they share a vertex, then they're an old style angle pairing from yesterday, the linear pair, or the vertical angles, or none of the above. B, its vertex, its pointy part is right here. A's vertex is right here. Are they the same? Are those the same point? No, those are two different points, right? Okay, so they're not an old style. They're not a linear pair of vertical angles. Then I'm going to check what side of the transversal are they on. Are they on the same side or are they on opposite sides of it? They're on opposite sides of it. If this is my transversal, one of them's to the left, one of them's to the right, or if you prefer above, below, when it's diagonal, that's fine. So they're on opposite sides of the transversal, which means it's going to be one of the alternates if it's any angle pair. What? Is it alternate exterior? Because the last thing we check is, are they outside of the two lines cut, inside, or is it one of each? Outside. They're both outside, which is alternate exterior angles. But those are essentially the three questions you have to go through. And for the most part, people can go through them pretty quickly. Question 2. That's a vertex, that's a vertex. Not the same. Transversal, same side or opposite sides of it? They're on the same side of the transversal because this is my transversal T. So same side means either corresponding consecutive interior or none of the above. Are they between the two line cuts, outside of the two line cuts, or is it one of each? They're both in between. Between and on the same side of the transversal is consecutive interior angles. CIA. Question 3. Technically, the first thing you should do is just ask yourself what the transversal is. The first line, the second line, or the one that's going horizontal? Which one's the one that's going through the other two? One that's horizontal-ish. Okay. A and B, not sharing the same vertex, so I move on from that. Are A and B on the same side of the transversal or on opposite sides of it? Transversal's here. They're both above it. So they're on the same side of the transversal. Again, that's either CIA or CA then. Are they between the two lines cut? Are they outside of the two lines cut? Or is it one of each? One of each. If it is one of each, that is corresponding angles. Now question 4 looks a little different. Do you notice that all of those lines are going through two other lines? So when it comes to recognizing which line is my transversal must go through two other lines. Technically, all of these are a transversal, but the important transversal is the one that goes through two other lines and connects the two angles. Here's angle A, here's angle B. The line that connects them is this one here. This is my transversal, which means these are the two lines cut by it, which means this line is there to throw you off. Ignore it. It's not helpful. If it's going through the same two lines as a transversal, it is technically in itself a transversal, but not a helpful one. Okay, are my two angles on the same or on opposite sides of that transversal? Opposite. One's left, one's right. Are they inside the two line cuts, outside the two lines cut, or one of each? Outside. These are the two lines. That one's above, that one's below. Opposite sides of transversal, outside. Opposite sides should start with alternate. Outside, is that interior or exterior? Exterior angles. AEA. Okay, two more of just identifying, and then we're going to get to our properties that go on our postulate sheet. This is my transversal. It's the line that's going through the other two. Are A and B on the same or on opposite sides of it? Same, they're both below it. Are they between the lines, outside of the lines, or one of each? Between, therefore, interior. Same side interior. Same side does not start with an A, it starts with a C. Interior is IA. If it's one of each, then it's just regular CA. Okay, last one that looks like this. Technically, this is my transversal. I could ask myself if A and B are on the same or opposite sides of it, but something else catches my attention first. This is angle A. This is angle B. Do you notice they share a vertex? Old style angle pairing. It's not CIA, AIA, AEA, or CA. It's either vertical or linear pair, across from one another on the X, vertical angles. And in all actuality, vertical angles do not require a transversal at all. Okay. Now, why do we talk about these angle pairings? What's the point of it? The point of it is because as we get a property involved, specifically as we get this property involved, we know something about the angle measurement of them. What's that symbol? Parallel. That symbol is parallel. If you have parallel lines being cut by a transversal, then we know information about the measurement of the angles. Now, before we get into actually filling in these properties, I'm going to draw your attention real quick to the picture. Do you see on this picture these little arrows hanging out on the lines? Those are parallel arrows. The lines that they hang out on are parallel lines.
Is that like before when we did with shapes, you would do notches?
You mean kind of like the tick marks for the congruent symbols? Yes, they follow that same idea. They're giving you the picture version of parallel, kind of like we gave you the picture version of congruent symbol. So similar to congruent symbol, if you ever see a situation where you have a bunch of lines, that you have parallelism, one set might have a single arrow, the other set might have a double arrow. Sometimes they fill in the triangle, sometimes they don't and just do kind of that symbol. But a little arrow on it indicates parallel. If you have parallel lines, our new angle pairings have some features to them. Corresponding angles postulate. C, A, post. states that if you have parallel lines, the corresponding angles are going to be congruent. Jasmine, you with us? So, corresponding angles in this picture. Corresponding means they're on the same side of the transversal. One's interior, one's exterior, without sharing a vertex. So, corresponding, I clicked the wrong button. Let's get back to that. That's the button I wanted. Corresponding angles, if this is my transversal T, would be like angle 1 and angle, that's the exterior one. I need one on the same side of the transversal, so either 3, 5, or 7, but one outside and one inside. It would be specifically 5, because 3 shares a vertex with it, so 1 and 3 would be a linear pair. 1 and 5 are corresponding angles, but that's just one pair of corresponding angles. Angle 2's corresponding angle would be 6. 3 and 7, 4 and 8. So, if you see if you see parallel lines, then you could say angle 1 is congruent to angle 5, or if you had angle 2 and angle 6, you could say they were congruent, or if you had angle 3 and angle 7, you could say they were congruent, or, I wrote too big at first, angle 4 would be congruent to angle 8. Those are all pairs of corresponding angles. You never have to say all of them. Generally, you only have to say one. But if you were to see a parallel symbol in a proof, you could say you have some congruent angles. We also have the alternate interior angle theorem. We know some things about the alternate interior angle theorem as well. Alternate interior angles are also congruent. Alternate means where on the transversal compared to one another, same side or opposite side. Alternate means opposite. Interior means where compared to the two lines between them. So alternate interior angles in this picture would be like angle 3 and angle opposite side of the transversal, but still between. It would have to go 6. It's not 4 because those two share a vertex, therefore those would be a linear pair. There's another pair of alternate interior angles here. 4 and 5. If you have alternate interior angles and the lines are parallel, then angle 3 could be said to be congruent to angle 6, or you could say angle 4 is congruent to angle 5 by the alternate interior angle theorem. Corresponding angles are the only one that has 4 pairs. Others just have 2 pairs in a single picture. Alternate exterior angle theorem. Alternate exterior angles. Alternate means where compared to the transversal, same side or opposites. Opposite side. Exterior means where compared to the two lines cut. Outside. So, I need outside, so I'll pick angle 1. The alternate exterior would be 8. Opposite sides of the transversal, still outside. Can't say angle 2 because they share a vertex. They're never right next to one another in these type of angle pairings. What's the other pair of alternate exteriors? 2 and 7. Alternate exterior angles are also congruent. Angle 1 and angle 8 could be said to be congruent if the lines are parallel. That's a key thing. If lines are not parallel, this is not true. Or angle 2 is congruent to angle 7. Be careful on the last one. Consecutive interior angles are not going to follow the same pattern. So don't get ahead of yourself and start filling in consecutive interior angles because you're going to likely be wrong if you do. Consecutive interior angles are different. Consecutive is the same or opposite sides of the transversal. Same side. Alternate gives us opposite. Consecutive or corresponding, those are same. Interior means between the two lines. So 3 would go with 5. 4 with 6. Alternate exterior angles are not congruent. Do not write down that they are congruent. Consecutive interior angles. By the consecutive interior angle theorem, the CIA theorem, are supplementary. So if you have this, you can say angle 3 and angle 5 are sup, as in supplementary, or you could say angle 4 and angle 6 are supplementary. When it comes to the problems that you do as we go through this, first off, parallel, if you're going to solve for x, parallel is necessary, otherwise you can't do it. But this picture here, which, by the way, isn't it the exact same picture on the postulate sheet? This picture can help you identify angle pairs, even if it's not parallel. Even if all you're trying to do is figure out the angle pair. For example, now we already did this problem, this question 1 from the top of this sheet, but if I struggled with figuring out what the angle pair was, I could look at this picture, essentially try to line up my transversal a little bit so it's kind of going the same direction. Vertical or horizontal is all I mean with that. And I can say, okay, in that picture, this angle here and this angle here, the two I asked about would be kind of like in what location on here? Okay, and I'm looking above and to the right, it'd be kind of like here. And then below and to the left would be like here. Knowing that it's angles 2 and 7, I could then look in the stuff that we just did here and say, okay, where are 2 and 7? 2 and 7 are in the same thing right here. Therefore, they were alternate exterior angles. I can use this picture to help me identify if I struggle to identify angle pairs. Anyway, let's get to our last page of notes, the last thing we're doing today. And the last thing you're doing today is solving. Label the transversal T, name the relationship between the given angles, and solve for the variable. Now I'm going to note something. Every single one of these pictures, do you notice that there are parallel lines? Arrows, parallel. Arrows, parallel. Arrows, parallel. Parallel, parallel, parallel. If you don't have parallels, you cannot solve. We do have parallels, therefore we can solve here. Okay, first thing I'm going to do is label the transversal. Transversal is the line that connects them. In this case, it's that one. I need to know what kind of angle pairing that is. Are they on the same or the opposite side of the transversal? Same side. Inside, outside, or one of each? Inside. Same side, interior? CIA. Are consecutive interior angles of parallel lines congruent or supplementary? Supplementary. What does supplementary mean?
So,
180.
They add up to 180. 141 plus 16 plus x equals 180. I combine my like terms. I end up with x plus 157. Combining like terms in a proof is called what step? Simplify. And I subtract 157 from both sides. X is equal to 23. Knowing that, I can solve. Okay. Question 8, I guess it is. Can't call on someone who's not here. 8. Which line's the transversal? First, second, or third? Hey. Are my angles on the same or opposite sides of said transversal? On opposite sides of it, so I'm thinking alternate something. Darnell, are they alternate interior, alternate exterior, or neither of them? Interior. Aaliyah, are alternate interior angles supplementary or congruent? Congruent. Cam, what's congruent a fancy word for? Same, or what symbol do we typically like for same in math classes? Equal. Congruent is a fancy word for equal. So 126 equals 4x plus 2. From here, it's algebra. You guys know the algebra. 124 equals 4x, divide by 4. 31? And I flip it around. X equals 31. Flipping it around is called what in a proof?
law of symmetry.
Symmetric property. Question 9 has got something a little different about it. Do you notice the question line 9 has extra lines on it? Yeah, there's some extra lines there to throw you off. It doesn't change how we find our transversal. Our transversal goes through the others, or if it's easier, it's the line that connects from one angle to the other. Jada, is the transversal line 1, line 2, line 3, or line 4? 4. You got it. Now my angles are here and here. Notice that line not involved. there to throw you off. Don't pay attention to it. Ignore it. Cross it off. Olivia, are those two angles on the same or on opposite sides of that transversal? They're on opposite, so I'm thinking alternate. Piper, alternate exterior, alternate interior, or not either?
Oh, no, exterior.
Exterior, because this line doesn't matter. If you're looking at that line, it's going to make it harder, but if you ignore it, it's outside of these two, so it's alternate exterior. Diego, are alternate exterior angles supplementary or congruent? They are congruent. Jasmine, congruent's just a fancy way of saying they're what again? Equal. 10x equals 40, x equals 4. Question 10. This is clearly my transversal. Aiden. What kind of angle pairing are we thinking for this one? Not quite. Are they on the same or opposite sides of the transversal? So I'm thinking an alternate of some sort. Are they interior, exterior, or one of each? Are they in between or outside of the two lines? Here's my two lines. Inside. So opposite with sides of the transversal is alternate, inside is interior. Alternate interior angles. Alternate interior angles, congruent or supplementary? I'm asking the group. Congruent, what's the only one that's supplementary? CIA. But remember the old ones come too, linear pair and vertical angles. Which of those two is supplementary? Linear pair. So those can still pop up. This one's alternate interior, which is congruent. 2x plus 1 equals 45. Do y'all trust my solving skills? X is 22.
It's 23. No, it's 22. Is it?
It's 22.
No.
Subtract the one, you accidentally added it. Question 11, that's my transversal. I trust we're making sense of that transversal right now. It's the angle pairing that is the thing that's going to mess with people. Charlie, what kind of angle pairing do you think these two are? They are corresponding angles. They're on the same side of the transversal. One's in between, one's outside. Corresponding angles. Mariana, is that congruent or supplementary? We'll look at the previous page. CA is this one? What's that symbol? Is that a congruent symbol or a supplementary symbol? You got it. They're congruent. In other words, they're equal. 11x plus 9 is equal to 10x plus 20. ... Trust my solving skills. X is 11. Question 12. I have two transversals. This is the helpful one. This is there to throw me off. Nate, what kind of angle pairing are these two?
Interior.
They are interior. Are they alternate or consecutive interior?
Alternate. No, the consecutive.
Consecutive. Yes, John?
Why don't it have the arrows on the transversal?
You're 100% right. A transversal technically should have have arrows if it's going to be a line. It's really because I cropped them out to make it where you could read it and it wouldn't take up the entire page. It's literally just me trying, because they're kind of tiny writings. And if I wanted to zoom in at all, it became a really big picture. So technically there should be arrows there. Peyton, consecutive interior angles, are they congruent or supplementary? You got it. Which means they add up to what again? 180. I can't solve this in my head. The other ones I just solved in my head, hence I said trust my math. Good. Same thing I got. Thank you. Okay. Last two problems. The key thing I want is that angle pairing. It's what we've been practicing at this point. Brody, what kind of angle pairing do you think is number 13? Are they on the same or opposite sides of that transversal? Good. Are they between the two lines cut or outside of them? Opposite is alternate, outside's exterior. Alternate exterior angles. They would be equal because they're congruent, and x would be 16. Final one. That's my transversal. They are on the same side of it. One's between and one's outside of the two lines cut. What kind of angle pairing is that? If one's between, one's outside, it can't be interior or exterior. What's the only one that doesn't say interior or exterior? Corresponding. Corresponding angles are congruent. We would set them equal. X would be 6. Okay. So. Today we went through section 3.1. Today is the 11th. Your homework's due on Tuesday. What's happening Tuesday next week?
Tuesday.
There is a quiz next Tuesday.